Afternoon, everybody. I don't know if you were aware, but there's this awesome thing called the internet. And if you're familiar with the internet, you probably know about Mozilla. And talking about scaling Puppet at Mozilla, we have Justin and Brian.
Thank you.
Thank you.
Can everybody hear me okay? Yes? In the back? All right. Either they can hear me or they can't. But, I get a lot of questions all the time about Puppet at Mozilla because as open source friendly as we are, we like to think of ourselves as the open source company. One thing we're terrible at is open sourcing our internal IT tools, like our Puppet modules. And really, our entire Puppet infrastructure is closed and it's not available to the public as of right now. It's something we're going to fix in the future, but so I'm always hearing questions about, oh, how do you guys have this set up? What do you do there? What, you know, a lot of questions around how Mozilla does Puppet, and so I figured I'd write a little talk about it, and then you'll know. So I guess I'll start off with kind of some of the technical details about our current setup as it looks today. The main goal behind everything that we do is, like here, the last bullet is that we have 1,200 Puppet node clients right now, but everything is set up in a way that we can support many more than that, maybe 12,000, maybe more. We try not to ever limit ourselves. You know, a lot of people are like, well, this will scale up to 100, but we'll never get there. Well, we always get there. So our current setup, in order to support the 1,200 clients that we have 6 main Puppet masters. This is kind of a legacy configuration because we used to just have 6 Puppet masters, and then as we kind of scaled outward, we needed a way to quickly be able to add more Puppet masters to deal with the computing resource of compiling all the manifests. And so rather than re-architect the entire infrastructure just to add a couple more Puppet masters and like behind a load balancer or something like that, we left the existing Puppet masters as they were, and then in some of our larger data centers, we added 4 more Puppet masters each. So that second bullet point, 8 auxiliary Puppet masters, that's kind of what I call them, and they're behind the main Puppet masters. So the client configuration, each Puppet client has like a Puppet master fact. It knows who its master is, and so when we made this switch from the old way to the new way, that didn't change. Each client still talks to Puppet 1 dot whatever, and then in the case where we have the auxiliary Puppet masters, it uses mod proxy and mod balancer to load balance to a pool of Puppet masters that are behind it, if you will. And currently we have 2 main Puppet masters that each have 4 auxiliary masters behind them, and then in some of our smaller data centers, we still just have a single master each. Uh-oh. Sorry about that. Keep that going. So that's pretty cool because that means that we can scale that pretty indefinitely. Obviously, these main Puppet masters are still a single point of failure. Like if one goes down, then the other 4 can't be reached. That's something that we're going to address probably in the near future. But right now, we're able to scale for load quite a bit. If we start getting overloaded, we just add more. We use a dashboard, and using a dashboard in this environment is something we've wanted for a long time, but it's been tough because we have 2 primary data centers, an office infrastructure with a lot of remote offices, and we have a couple of smaller data centers as well. And the problem is that when you think dashboard, you think like, we can just add the dashboard to our Puppet master. But if we have a total of 12 Puppet masters, where do you put the dashboard in a way that you can kind of see an overview of the entire infrastructure? That's always hard because each Puppet master doesn't know about the other Puppet masters and other data centers and stuff. But when I look at my dashboard, I want to see all 1,200 nodes at once. I want to see what's unresponsive where, where are my errors at. I don't want to go log into 6 different Puppet masters. So the way we kind of solved that, we consider our dashboard, we're just using the open source dashboard, not the enterprise console, but the open source dashboard. And it's its own little web cluster behind a load balancer. We started with 1 web node and a separate database server. That fell over pretty quickly when we had 1,200 clients submitting reports every half an hour. So we added a second one, and then it got a little bit better. And then with 3, we're kind of happy right now, but we'll probably be adding a 4th one soon. And so the way that works is that there's a VIP behind a load balancer. Each Puppet master submits its report to the dashboard, and then each dashboard node has an NFS mount that's shared across all the different nodes. And so whichever worker is available to pick up that report to process it can do that and insert it into the database. The database is, I have down that I've got 2 database servers. I'm only using 1. The other is just a, kind of a standby. It replicates from the master, but in case, the master goes down, I can just move it over and keep going. I don't think that the Puppet dashboard has any ability to utilize 2 different database servers. I know a lot of websites out there can do like send writes to one database and reads from another database. I'm not sure if the dashboard supports that. So it does a master-slave failover. Like I said, right now we have about 1,200 clients total today, but what I want to stress is that our environment changes very often, and I'll say these 1,200 clients that are in production today are not the same ones that were in production last week or the same ones that will be in production next week. Most of them are the same, but there's probably 100 that change on a week-to-week basis when we have old projects that are being retired and new projects that are coming up, and so things change frequently. It's not like the same 1,200 nodes. Our team, the overall IT team of like 50 people, there's upwards of hundreds of commits to our Puppet tree a day in our SVN. Stuff's always changing. So I want to talk a little bit about how we provision a new node in Puppet, because I know a lot of the how-to guides out there kind of talk about, install Puppet and then generate a certificate and then go sign the cert on the master. And it's like a tedious process. And then, and I think everyone does this a little bit differently. There's auto-signing, different ways of doing stuff. Our security team isn't completely happy with us doing auto-signing, so we're not doing that yet until we can find a better way. I think one of my colleagues in a different department at Mozilla has figured out a secure way of doing this, but it's a convoluted thing. It's a project called Puppet Again. If you look it up online, it's an interesting thing, but I won't get into it because I don't know how it works. So basically, we have an operations team that does most of the hardware build outs and stuff. So someone will say like, hey, we need a new web server for this or that, or just we need more servers in this cluster or something. So the minimum amount of work that we have to do is basically name a server, put it in our inventory system, put it in DNS, DHCP, standard stuff to make sure that it gets an IP address where we expect it to, and install an operating system. That's about the most work that we want to do, and that's stuff that we're looking to automate also, but it's a little bit outside of the scope of what we're doing with Puppet. That might be something for Razor or something else later on. But the other thing that we're not using PuppetDB or stored configs, so we don't have the magical automation and nagios. When they add a new host to inventory, they also need to add basically one line to our nagios module that says, here's this host exists and it's a web server. The rest is all automatic. It's pretty cool. But then to actually get Puppet up and going, we have a little puppetize.sh script. So you go to the Puppet master and you run puppetize.sh. That script does a couple interesting things right off the bat. Here's a list of a lot of things it does, but the most important thing it does is that it sets the host name on the remote server to match what's in DNS. So we're basically using our DNS as a source of truth. The nice thing is that we can force a host. I mean, that's one way to change a host name. So puppetize it. So once it does that, so it basically checks that DNS matches what I gave it in the argument to the script, and then it also logs into my inventory database to make sure that the host actually exists and is named properly. So if someone typoed the name in inventory or in DNS, or I typoed something, somehow it won't generate the cert with the wrong name. So it does all these things before it really proceeds. If those couple things pass, then the script just kind of runs through a bunch of stuff like updating some base packages like glibc, and I I think Yum itself, I don't know, it updates a couple things, just regular maintenance stuff to make sure that we're at the right version that we want to be at. And then installs Puppet. Oops, I didn't know how to do that. So it installs Puppet. It grabs the Puppet Labs Yum repository, we have a mirror of it, and it installs that, and then installs Puppet. Then it generates and signs a certificate on the Puppet master that I'm puppetizing from, and then it copies it over. This is something that's been in place since, I think, before I started working there, so I'm not sure of all the security implications of doing it that way, and then it deletes the key from itself, so, but it gets around the whole generate it on the client, then wait for cert, and then sign, and so it's a little bit easier. It's a one-step process just to go to the master and say, here's a new client, do what you have to do. Then I don't have a lot more logic than that in the script. I don't want to try to hard code things like this is your server and this is how you should have puppet.conf and this is how you should do that. Because these are all things that change over time, and when I change them in Puppet. I don't want to change the script. So the script basically does the minimum amount to run Puppet. It runs the base module, but it runs Puppet agent, test, plugin sync true, server equals the host name that I'm running it from. And the rest of all that stuff that node needs, like the base stuff, like SSH keys and all that kind of stuff, that's all done by Puppet itself. So it basically gets the first Puppet run going, and then it applies a minimum of my base module, which I talk about right here. So the PuppetConf is also managed by Puppet. It's not like something I copy over everywhere. It's just managed by Puppet. It's really nice because there's a lot of times in the past as we've scaled out and we've had to change some things. We've had to change puppet.conf. And then it became apparent that just copying it over once and then saying, that's our PuppetConf. No, we're always changing things, like changing the different options. Like when I deployed the dashboard, I needed to say like report equals true and send a report and that kind of stuff. So it all goes out with as a Puppet configuration. Often, of course, when we break it, then we've kind of shot ourselves in the foot. So it'd be a good job for like mcollective or something to go and fix, but we're not quite there yet. Anyway, so we up until that point, it's all been manual. But then with the base class that we have, this gets applied to every single node regardless. And I don't think I even built in a provision to exclude a node from that because I don't want to. There's I can't think of any reason that any server in my data center, in my infrastructure, should ever not have a bare minimum of things that everything needs to have. So most of our stuff right now is Red Hat, so I put Yum repositories. We do have a couple of Ubuntu, and I think maybe one or two Debian servers. And there's actually a conditional statement for Yum repositories, apt repositories, but basically this base class, it installs all these things on every node using proper conditional statements that are basing things on facts, like an HP server will get like the HP health daemon, a Supermicro server will get the IPMI tool, IPMI daemon, and stuff like that. But for the most part, this is kind of what everything gets. Puppet configurations, the cron job, the shell settings for a root user, the root password, the NRPE settings, audit D settings. We use audit D for our security team, like tracks everything that happens. Custom scripts, NTP, general, I mean, all the things that kind of need to be done gets all pushed out by this base module. And that's pretty much it. I mean, if we have anything beyond that, then we can create a node definition. But if I have no node definition or anything like that, by default, everything, like I said, gets at least the minimum things. Now, if I have a web server, aside from the minimum configurations, I would create a node definition and say include HTTPD or whatever, whatever module I have. Currently, we're keeping all this stuff in, in flat files, and generally, there's like 200 files under this path, and each class of machine gets like their own file with the list of machines in it that have those classes. So it's kind of a mess, but so we use grep a lot. We're not quite to the point where we're ready to offload everything onto an ENC or something like that, but we do have an ENC. I think I'll get into that in a minute. But anyway, so this is where all the specific data goes, and we're trying to get everything from our modules into parameterized classes, and then this is where we kind of put in those parameters until we get onto like newer stuff like Hyra. But meanwhile, this is how we do it. We try to put all the manifests, all the parameters into manifest nodes, and that then becomes our kind of secret area. And if we can succeed in doing this, then we'll be able to open source our modules themselves. Get into that in a minute. But we do have an external node classifier, like I mentioned. Currently, all it does, though, is it checks our inventory database to make sure a node exists. So it's a little bit of a security precaution that not any random thing can be puppetized unless like someone's actually logged into the inventory database and said, like, yes, this node exists, and this is its host name. And it's actually what happens to push that base class on everything. We used to use this for a couple other things, like pushing. We used to do a lot of like name-based stuff, like a web server would have web in the name, and then it would automatically push like a web class. And so that's why we have this script. It's a really old like Perl script, and it has the ability to push classes based on names and stuff. But meanwhile, all that stuff's kind of deprecated, and we stopped doing that. So it pretty much just pushes a base class on every node, and that's it. And then I think I talked a little bit about the dashboard already in the previous slide, but here it is again. It just, like I said, a cluster of, I think it's 3 virtual machines and then 1 hardware server. One thing that is interesting to note, and if you're planning on deploying dashboard in a large environment, especially if you want one dashboard in a distributed environment, is that with the 1,200 nodes, we can keep maybe 1 day's worth of reports, and then we still kind of run out of disk space. And that was when we had like 120 gig hard drives. So now I've upgraded these database servers to 600 gig hard drives, and I can keep like 3 days. I'm pretty happy. So that's an area for improvement still in our infrastructure. But yeah, that was something when I first rolled this out. It was like our DBAs were getting paged every night, like, hey, your dashboard's full again. And I was like, I can only tell it how many days. I don't know if I can tell it hours to prune. So I have the cron jobs running every day to prune and optimize the database at 2 a.m. And then they get paged for like it being overloaded. But anyway, so the dashboard thing, I'm not convinced it's definitely the best tool out there, the right tool. It's been a lot of trouble. I think we're gonna hit limits there before we hit limits in the rest of our infrastructure. But because it's kind of a read-only dashboard, we're not depending on the dashboard to be there. If it's not available because it's dead, then Puppet still continues to run. And we have some other feedback tools that we can use to keep an eye on things, and we'll get into those in a bit. But like I said, it's just for reporting, and I'm not sure that I would really want to do anything much more with it. Like, I know the enterprise console does some more stuff, like it can be an ENC and stuff like that. Not sure I'm ready for that with the dashboard because of the scaling problems it has. But that being said, we have our own inventory application that is pretty cool. It's open source already. One of our developers' name's R. Tucker, so it's on here, R. Tucker Mozilla. There might also be another one under the main Mozilla repository that's like a fork or the same thing as this. I'll have to ask him. But anyway, in the meantime, you can check this out. It's just a Django Python app. It's been around for years, but it's changed. It changes frequently, and it's changed a lot lately. And the most recent thing that he and another developer wrote into it is support to basically accept Puppet facts through a REST API. So we have basically a cron job that can run on each Puppet master every half an hour or whatever, and gather up all the facts that it knows about and can submit it into our inventory database. So now, once a host is puppetized and everything, we can log into our inventory database and look at the host that we just added, web1.mozilla.com, we'll say. And as long as that cron's ran, now we can look in our inventory database and see all the facts about it, the kernel version, Ethernet, everything. Make sure everything matches up to what we think it should be. And that makes for a lot of, helps us get rid of a lot of manual stuff, because the old version of the inventory database, it used to ask like, what operating system is on this host, and which, is it 32-bit, 64-bit, like all these different things. You'd have to like manually go enter in, and then if you like rebuilt a host, you'd have to go and change all those values. So now it's all pretty automatic with Puppet, and that's pretty neat. And it can generate reports too, so I can, if I just want to say like, hey, I need there's a kernel vulnerability, so I need to get every single host that I have that has this version of the kernel. I can pull that, and then I can schedule appropriate downtimes for those hosts based on that report. So that's something that it's a brand new feature. It's in beta right now, and it's pretty awesome. Pretty happy with it. That's our inventory. Modules. Probably a year and a half ago, we didn't have any modules. We had just a bunch of classes and like manifest classes, trunk manifest classes. And it was a complete mess because there'd be like one file with like 14 different classes in there that all inherited each other. And it was kind of a big mess. And then as a team, we took some training from Puppet Labs, and it was great. We learned everything that we were doing wrong. And in the last year and a half or so, we fixed it now. So now we still have like a few, but probably like maybe less than 10 of those random classes sitting about, and they're all legacy stuff that's still using them. But everything else, we've got modules. We have about 141 modules. I say about, but it's exactly 141 modules in our module path. And I would say all but just a small handful are home built. The reason for that is I think when we started moving everything to modules, we'd look at the Forge, and back then the Forge had like 60 modules, and they were all crap. I don't know. Or they weren't what we were looking for. They were like, this works on Ubuntu and Debian and Slackware, but we're on RHEL, So like today when I look at the Forge, it's a whole different landscape. I'm not saying the Forge is bad. The Forge is awesome today. And now we regularly go and grab a couple things. But so far, there's only a couple things we grabbed from there because we already have 141 home-built modules, and what else do you need? But I think that's something that we're really proud of in general, is that we do a lot with Puppet. I mean, if you look at most other companies, or a lot of the larger companies, when you say like, oh, well, Mozilla's only got 1,200 servers, but like Zynga or somebody else, they've got like 50,000 servers managed by Puppet. But they're all running like the same application, like Facebook. They've got web servers and database servers. We've got 141 different types of servers that we're managing with Puppet. And I'm really proud of that. Like, we manage everything with Puppet. We mostly rely on security for Puppet for security stuff. And when I say that, it's our security team gives us directives like we can't allow password logins on SSH. We can't allow random daemons to be running. We have to, make sure everything's right. They want to log everything, so they have syslog settings that are important to be on every host, and they have monitoring. I don't know how they do it, but they have monitoring if a host stops sending logs, then they know about it. So they kind of have this whole feedback loop. So we use audit-d for that and specific syslog settings, and those are in our SSH settings. We make sure we don't allow password logins. We turn off root logins where possible, stuff like that. And so these are like the #1 security, security networks, security things, and we use Puppet to make sure that that happens. And so what happens when a host is in production or on our network that's not in Puppet or isn't checking into Puppet regularly because something's broken on it, or someone disabled Puppet because they were trying to do something, or even if there were a compromise and someone, first thing to do is turn off services like Puppet. So Puppet's really important to us. Like, it needs to always be running. It needs to be checking in, and like if it doesn't check in for an hour, then something's wrong and we need to investigate it. It's a big deal because things can happen in an hour. So because of that, we have nagios watching every Puppet client to make sure that Puppet is running properly. And like I said, if it stops checking in within an hour, then we get alerted for it. And the way that works, we have basically, and I think this is out there on, or a version of this is out there on like Nagios Exchange, check Puppet freshness. We've modified it a little bit, and it gets applied to every node, and it basically reports an error if there's an error in the last run, or if it hasn't ran in a while. So like if someone stops the cron job from running, and after an hour, we're going to note about it. So, and we don't have these like pager on-call sysadmin like we do most stuff with Nagios. We just have like an IRC channel, and we have a Nagios bot that alerts everything into an IRC channel. It's pretty cool. That Nagios bot's also open source and should work with any Nagios. It's on our Tucker's site on GitHub. So that's cool. And But because of that, one of the largest problems we've had around scaling is that we have different teams that use Puppet, and so like my team is a very small team of a couple people that it's our job to make sure that Puppet's running, and the security team comes and yells at us when they say, hey, this box stopped logging or this happened, and all I can say is like, well, it's checking into Puppet, so, you know. But what happens is that all the other teams, they often, when they're deploying something new, they're testing something, they're trying to troubleshoot something, they need to put in like a debug line in their config file or something like that, and Puppet's going to come through and like clobber that, and then it sets them back an hour. So the first thing pretty much anyone does when they need to troubleshoot or test something, they log into a box and turn off Puppet. And how they do that, it used to be running like Puppet T-disable, but then there was like some bug with that in one of the versions. I don't know if anyone remembers that. So we went, or what it would do is that it would never enable again or something. So we had to, we changed our cron job to be Puppet D-enable, and then semicolon Puppet D-test. So if someone would like disable Puppet that way, then it wouldn't do anything. So people started getting really tricky, like remove the cron job. But it's fine because running Puppet would put it back. But the problem is that we have a splay equals true in the config, which means that oftentimes Puppet starts and then it sleeps for some random amount of time and then it'll run. And if you catch it in that sleep time, someone logs in, removes the cron job, Puppet's actually still running, and then it puts the cron job back next time when it actually starts doing stuff. So people started just stopping cron altogether, just kill cron. I think I even have this. This is the list of people. So people will stop cron. The other thing I've seen people do is just chmod 000 user in Puppet. That's also a pretty hardcore way. So like all these, and these are all different ways that you can disable Puppet, and it works great. But the problem is that for every sysadmin at Mozilla, at least, that knows how to disable Puppet in a unique way, there's a sysadmin at Mozilla that will not remember to re-enable Puppet when they're done doing whatever they were doing. And so what happens over time is like we would get to, like my team usually spends half a day on Friday kind of going through the dashboard, looking at all the nagios alerts and saying like, all right, these things haven't checked in, this is broken, these are some errors here and stuff like that. And what we'd find is that like over the course of a week, we'd have like 100 nodes that have gone stale for some reason. We log in and then we look and we're like, okay, this one doesn't have cron running, this one has the cron job removed, this one has chmod 0, different things. And then but we never know who did it, so we'd like, yeah, we'd have to go track down security, or we're usually pretty good about figuring out like, okay, usually this guy works on this box, so let's go ask him. We wait for, but we're so distributed, people in different time zones, and so it's usually like ping someone on IRC and then wait 4 hours till it's their work schedule. Then they come online, they're like, and usually it's like, oh yeah, I forgot to re-enable that, last time. But every now and then, so you'd think like, oh, if I find it like that, I can just re-enable it, call it good. No, but like every now and then, someone will say like, oh no, I disabled it on purpose, and it's of utmost importance that you don't re-enable it right now, because if you do, it'll break like all our production websites. Trust me, it's like that on purpose. And I'm like, all right, cool. So when's that going to be resolved? Why can't we fix this upstream? Like, why is just half your stuff not in Puppet right now? And there's never a good reason. People are like, oh well, I'll get to it later and stuff like that. So there's either a reason for it to be disabled, and then if I go fix it, I get in trouble, or there's no good reason for it to still be disabled, and then if I go ask someone, they get annoyed with me, like, oh, Jabba, you're always asking me about Puppet. Like, just leave me alone. Like, let me disable stuff when I want. And then my security team comes ask me, like, hey, half our stuff's not checking in. And so it ends up being a big deal, and I get caught in the middle. So we have a solution for this exact problem. And oh yeah, this is the other part of that, is like always asking why Puppet's disabled. And people, there's either a reason or there's not, but it's you always got to know why. If you don't know why, then you can't re-enable it safely. So Brian wrote a great tool. It's called PuppetCTL, loosely based on the Apache CTL type of a tool. So I'm going to let Brian talk about that for a few minutes.
So we have this tool that allows us to disable Puppet. It tracks who disables it, and they have to give a message of why they disabled it. So it's pretty cool. So you can also run a status. It says the last time Puppet ran, if there are any errors. And this actually ties into nagios. So when nagios checks a host, see if there are any errors in the last Puppet run, it can say, okay, it was disabled, everything's okay. Or it says, no, there are a few errors, and it's not currently running. It uses to re-enable Puppet. So you can use
That's on the next slide.
That's on the next slide.
Yeah, right here.
Yeah, so it's actually a wrapper around Puppet agent. So when our cron invokes puppetctl run, that will run Puppet agent and execute the code. Still with our -- enable hack in case someone tries to disable it. And then it uses that utility to re-enable Puppet at a later time. So you have to say now plus 1 week, now plus 1 month. I mean, you really could do now plus 1 year, but hopefully nobody's really doing that. And also adds a message to Etsy MOTD. So if our on-call staff gets paged with something going on, or security guys, their software stops logging, they can log in and they immediately see that someone is working on Puppet, and they know how to ping someone on IRC and find out what's going on the actual host. It's tied into our nagios check. So if someone disables Puppet, it temporarily disables our nagios alert. So if it hasn't ran in a few hours, everything is all good. You can also query the nagios bot to see the status of this, and in that little status message, it'll say who disabled it and for what reason. It still displays all the information that we need.
But if someone disables Puppet the wrong way, it will still send an alert. So that's our...
Absolutely. Then we have to go look and see
right.
who disabled it. The regular cron job uses a puppetctl run. If Puppet has been disabled with puppetctl disabled, it will still exit cleanly, so it won't throw any errors. Puppetctl disable with no further arguments does a default 1 hour downtime. So it records who disabled it, and it'll just do a quick disable for 1 hour. So if there's something going on that you need to just check out real quick, you don't have to do long arguments with a long reason and an @specified time. Some people were confused whether what argument the time format was in, whether it was a duration or when it should be disabled or the window. So we added that quick little shortcut to help improve everybody's life.
Yeah, usually what I do is I can't figure out the @ syntax, so I log into a host and I'm like, oh, I just committed this thing. I need to test something real quick. I just need to disable Puppet real quick. And then by the time I figured out my @ syntax, it's too late. It's already ran, and I've got to go do it again. So that's the big thing with the short version. I do puppetctl disable, and then I've got 1 hour that I can use to figure out my @ syntax to make it long, schedule for a longer downtime. So.
And it also, the run command supports arguments. So if you want to do no op debug, you can pass all those arguments, and that'll get passed to Puppet. So if you want to see some extra information, you can do that without having to modify the script.
So now do you have like 50% of the people doing the quote-unquote right thing and 50% of the people still doing the old way?
Well, we get a nagios alert if they do it the old way, because Puppet hasn't checked in.
It's starting to get better. Yeah, there's still one or two that haven't learned yet, but now we know who they are.
So the future of Puppet and Mozilla. In the coming months, we're investigating Hira. Right now, our Puppet code is closed source. We have some secret information, some SSH key stuff that probably shouldn't be in there in the first place. So we're going to all put that in Hira and hopefully encrypt it. That will allow us to open source all of our modules and share it so everybody can benefit from it. You want to talk a little bit about PuppetDB?
And then, as we learned this week, if you guys attended the PuppetDB talk, I investigated a little bit before. It looks really cool. Because of what I mentioned at the beginning, how when we provision new hosts, we have to take the extra step to go to our nagios module and add that host and a host group for it. I think that using PuppetDB, which is like what stored configs used to be or something like that, we should be able to kind of automate a lot more of our monitoring and just get kind of a better overview of what's doing what and share exported resources. So that's something we definitely want to do. I heard that, I don't know, is Puppet 3.0 out now, or did it?
Yes.
Okay.
7 last week. Nope, 2:49 p.m. 3.0 is live.
Okay,
Nice.
so that I think I heard something.
No
So
RC9?
so
I could ask the guys.
we are always on the bleeding edge. We're on the latest in 2.7 whatever, and as soon as Puppet 3.0 comes out, which is now, first thing we want to do is go upgrade. But we'll probably have to spend a couple weeks actually fixing a lot of our code, because I hear a lot of the stuff that we're doing wrong will actually stop working now. So that'll be something we'll probably address in the next month or so. And then, like I said, once we kind of have Hira in place, and we can audit all of our 140 some modules to remove any of the secret information or hard-coded stuff that would be useless to other people. We're going to start open sourcing a lot of that stuff. Partially, not so much to like reinvent the wheel and say like, hey, here's an SSH module, you know, because there's like a million of those already. But a lot of things that's really been interesting for Mozilla from the development side is that people are always wanting to contribute code or something or somehow help out with the project. And for our websites or Firefox code or anything like that, all of our stuff's open source. You can go submit a patch or something to a bug, and that's great. People come to IT are the same way. Like they want to help out. They want to be involved somehow in IT, but they're sysadmins, and you know they don't do regular code, but they know Puppet. They can do this and that. And we're always like, yeah, that'd be great, but like right now we don't really have a way for you to help us, and so we need to help you help us, you know. And so that's a big thing that we want to do is kind of get all of our Puppet stuff out there, because then we can actually accept help from the community, and that's a big thing for us. And so that's that, and then the but speaking of open source, PuppetCTL is open source right now. It's our first thing in the Puppet realm that is completely open source. Do you want to talk about that at all? Or?
So it's the first script that we're able to open source. You're encouraged to check it out, see if it's any use to you, report bugs, add improvements. And the same GitHub repository is going to be where we're going to release all of our Puppet modules as we're able to do so. Hopefully we'll be able to release them as we sanitize them from sensitive information and hard-coded paths, but eventually this will contain everything that we need to run our Puppet infrastructure, and we may eventually even pull our own code from there, so we can accept community submissions and feedback from everyone.
Yeah. So check it out. It's GitHub. If you can't read it, it's github.com/Mozilla-IT. Not to be confused with the other Mozilla repository, which contains our websites. So. And I think that's all we've got. Does anybody have any questions?
Put up the URL for the Mozilla inventory.
Yes.
I think it was github.com/rtucker-mozilla.
Yes. And then underscore Mozilla, or sorry, /Mozilla_inventory.
If anybody else has any, for the people streaming, there are a lot. You can run a mic to you. There we go. Too much dessert.
So what happens if somebody just decides to uninstall Puppet instead of disabling it or stuff like that? Like
So-
what'll happen? Will Nagios complain? Or?
Yeah, Nagios will alert because
okay.
Nagios will look at the last time that what is it, varlib Puppet something?
Last date summary, I believe.
Yeah.
Okay.
It'll look at that YAML file and let's see when the last time it ran.
Yeah.
If it can't get a timestamp from that file, like it was removed, then it's still just going to say, I don't know when Puppet last ran, and it will throw a Nagios alert.
Oh, okay. Cool. Cool. Wait, so are you doing anything interesting with the Puppet dashboard either? Like anything other than just looking at it to get a...
Yeah, it's just for looking at and we can see in dashboard. So if a lot of people disable Puppet using the PuppetCTL disable, that'll stop Nagios, but those nodes will still become unresponsive in the dashboard.
Yeah.
So it's kind of like our secondary kind of monitoring. So if I go see that, like, hey, these 5 nodes are disabled, I log into them all and I say, hey, someone disabled Puppet for a year, then we still need to go have a talk with those people. So that's kind of our backup for that.
Have you guys ever seen, there's a GitHub project, Puppet Dashboard Add-ons. Have you guys seen that at all?
I think I've heard of it, but I haven't actually looked at it.
It's a way you can get at all your node data from dashboard programmatically and stuff.
Oh, interesting.
Yeah, it's pretty cool.
Excellent. We've been doing wgets in the CSV file, and we export that to tools that run various analytics on dashboard stats. One thing that's very helpful is the pending resources. When we deploy a site-wide change, like recently, there were some users on systems that Puppet didn't know about, so we wanted to set user resource to purge users that didn't know. But we first wanted to take inventory of what these users were, and they might be important. So we use that pending list in dashboard to go and investigate, and then add these user resources to the Puppet manifest. And once we got that pending resource down to 0, then we added purge true, and it deleted any users that we no longer wanted.
We're a little low on time, so it's the last one.
Okay. So I wrote a script to do exactly what you did, to a local check for nagios to see if Puppet was running and what was the status of the last run. The problem I had is that sometimes, for some reason, the nodes couldn't reach the Puppet master, or for some reason, maybe wrong configurations, or a network issue, or something like that. And I had a lot of noise in nagios. So did you have some problems like that?
I think at first we did have quite a bit of excess noise when we first rolled it out, but we've patched up the script quite a bit to kind of catch all those sort of edge cases for false positives. And at this point, I mean, if a Puppet client can't reach its master, then we do want to know about it. So obviously in that situation, we'd still get an alert. But I think meanwhile, it's pretty solid. We haven't gotten any false alerts now.
Yeah, the majority of our errors are issues compiling the actual catalog. If someone makes a typo on a resource that is applied to 1,000 hosts, we'll get 1,000 alerts rolling in. That's primarily the largest source of noise. Eventually, we want to tie that into SVN, so we know who checked in a piece of code that broke everything, and sort of CC them on the notification, and sort of tighten that up a little bit.
Yeah. And I think that nagios check, we'll probably add that to our GitHub pretty soon too. I don't think there's anything secret in that, is there?
Yeah, yeah. We'll add that
look for
this
that
evening.
All right.
Thanks, guys.
Thank you.